What's up everyone, it's Problem Solver over here, and today I'm going to be teaching you about fire and why fire needs oxygen to survive. Okay, so in fire or in a flame there are three basic ingredients, which are heat, fuel, and oxygen. So without any of them, nothing would happen. There wouldn't be a flame, there wouldn't be a fire. So you need heat, fuel, and oxygen, all of them, to make a fire. So heat is, well, it's just heat, it's warmth. It's what you feel when the sun is out. So you could get heat from a matchbox. Like when you strike a match head against the matchbox, the friction is going to start a fire and make it warm. It could also be like a lightning in a storm. A lightning bolt or something could hit a log, which could start a fire. And then fuel. So fuel, now a lot of days we think of fuel as gasoline or something which makes a car move forward, backward, or just makes a car function. But fuel isn't only that. Fuel can be anything that burns. So gas is obviously one of them. Another thing could be a log or a piece of wood. And like that's how you make basic campfires, and some newspaper, which could be like the kindling of the campfire. So oxygen makes 21% up of the air, and but fire only needs 16% oxygen. So it can survive for some time without that much oxygen, but it would need oxygen to continuously flicker and burn. So us as human beings and people, we tend to think as warmth of a feeling of heat on our skin, and the hotter it gets, the warmer we feel. So that's basically what happens when we feel warmth. But for atoms and molecules, that's not it. So when atoms feel a little bit of heat, they get like antsy, if you want to say that, and then they start to move around. So it could be like 10 degrees Celsius, which is about 52 degrees Fahrenheit, then they could be moving around a little bit. But then if it gets to 20 degrees Celsius, which is about 72 degrees Fahrenheit, they could start moving around even more. And then even more, and the hotter it gets, the more they move around until the bonds break, and there's no more bonds, and they're just floating in space. So for example, wood has mostly carbon, hydrogen, and oxygen, and also some other elements or atoms inside. And like when it gets hot enough, or like when the sun is beaming down on a piece of wood, or when you light a flame to a stick, then the oxygens, the hydrogens, and the carbons, so they might start moving around, and they're all bonded together. Not like this, but they might be bonded together in a different way, because I have no idea what wood looks like on the inside or in the biological form. So they may start moving around, and then when it gets hot enough, like I said before, energy and atoms are released into the air, which is called oxidation. So, oxidation. That's what happens. So, the atoms, when atoms meet up into the oxygen, and then they pair together with different atoms, that's called oxidation. But then the other atoms, which can't bond in time, or they don't have a different atom to bond with, they're just mingling around the oxygen, waiting for something. And that is when you see on the flame, that's that blue light underneath. That blue glow underneath. So in wood, the carbons, so the carbons and the oxygens make CO2, which is that black smoke, which is that colorless smoke, which just leaves the fire pit or fireplace or whatever. And then hydrogen and oxygen make H2O. Okay, I did that the wrong way. H2O, which is not just liquid water, it's just water vapor, because you can't automatically get liquid water when there's a fire raging, unless you spray it on. So it's obvious that since oxygen is in both places, you're going to need oxygen for making a fire, because carbon and hydrogen don't meet. So if you think about it, if you have a flame at home, or if you have like a candlestick and you put a glass over it, it's going to flicker for some time, maybe around less than a minute, and then eventually it's going to go out because there's no oxygen for it to keep on moving or flickering. So then the light will just go out, because then there's only going to be hydrogen and carbon atoms left. But if you have a bigger cup or whatever, then there's going to be a longer time that the candle can stay, because there's going to be more air, which means more oxygen for the fire to work with. So then the fire would stay for a little longer, then it would eventually flicker and die out. So that's how fire works, and that's why fires need oxygen to survive. If you enjoyed this video, be sure to like and subscribe. And yeah, comment.